Hello, good morning, good afternoon, and good evening, depending on your part of the world. This is Nate Miller. I'm the founder and CEO of Proving Ground, and I hope everyone is safe, happy, and well in your various corners of the world. This webinar will be covering a number of interesting opportunities and capabilities of our PG app suite, in particular, how the tools that we have been making can allow users to connect across various platforms and essentially create a data-driven story for your project or in your business. I'm joined by Nicole Mader, our Director of Product here at Proving Ground, who will be going through a live demo here shortly. But before we get into that, I wanted to maybe set the stage with a couple of concepts and a little bit of orientation. So we are a small digital design agency based in the United States, and our operating I guess theme or kind of vision is this idea of helping to create a data-driven building industry. And what that means is not only equipping teams with tools and technology, but also enabling learning and facilitating the change of process and really thinking about problem-solving methodologies that allow professionals in the building design and construction world to take advantage of their data and make it actionable. And as consultants and service providers, we've been fortunate enough to be a part of a number of very amazing and interesting projects that have required a level of innovation when it comes to digital process. And a lot of the tools that you'll be seeing in our workflows today really were born out of a lot of these project engagements. So we were, fortunate enough to be a part of projects like the Gilder Center, currently under construction in New York, designed by Studio Gang, which involved the creation of a lot of interoperability workflows and the uses of computation. We worked on the Lucas Museum of Narrative Art with Stantec, which is the executive architect on the project, to help facilitate ways of analyzing the geometry, as well as facilitating workflows for connecting this geometry into platforms like Revit, as well as looking at projects like the Allegiant Stadium, the current home of the Raiders, where we were brought in by Mortensen McCarthy to help create a level 300 model to facilitate construction sequencing and coordination. And this process used a mix of Rhino, Revit, Power BI, and a whole host of other considerations for data integration. And it's really with this context that we embarked on creating a number of tools that can be used to facilitate the transfer of data across platforms, the integration of data for insight and analysis, and the presentation of data with various reporting systems. And one of the things I like to emphasize with the apps that we're building is that these are being built with familiar platforms in mind, and they are technologies that can be used today in different capacities. So we know that professionals are using tools like Rhino in their practice to develop design ideas. And so tools like Semantic really play a role in facilitating the data integration of different properties and exports of data from Rhino. We also know that Revit is the kind of preferred and most widely adopted building information platform, certainly in North America, but arguably across the world. So we know that integration within that context is important. Being able to transfer data into Revit and out of Revit for coordination and design development is critical. And finally, we know that firms have access to tools like Power BI. Power BI is a business intelligence tool that lets you make interactive reports. And we've seen kind of growing adoption in this as a way to present data-driven ideas. And so these apps are really aimed at connecting those platforms together in a kind of comprehensive way. And so as a bit of a preview, just to kind of set the stage here, you'll find that we're going to be using different plugins in the PG app suite. Conveyor is one of the tools that we offer that allows for Rhino Revit integration. The emphasis with this toolkit is to provide user-friendly interfaces for transferring data back and forth. So you can, transfer geometry and properties across these two platforms without having to use computational design tools or have know-how in, kind of coding related interfaces. It's kind of no code transfer of building information modeling across these environments. And our aim is to try to continue to make this a process that is easy to adopt, and then we have pathways of integrating with computational tools in case you need more bespoke workflows, which you'll see I think in Nicole's presentation. We also have a tool called Semantic. Semantic is used to build and integrate data into Rhino. And then it also features a toolkit for visualizing Rhino-based information within the Power BI environment. So the idea being that you could have a data-rich model even in the earliest stages of design, and then you can take that model and use it as a presentation asset within the context of a reporting and interactive dashboard in the Power BI environment. So the information you're seeing kind of on screen here are various models being presented within Power BI, initially authored in Rhino with data driven from Semantic. And then the other tool that you'll see in today's presentation is a tool called Tracer. Tracer is a tool that lets you extract data and geometry out of your Revit models. And this then allows you to start to construct reporting that uses that information. So we've seen use cases of Tracer range from the presentation of spatial data to the presentation of construction sequencing within the business intelligence environment. We've also positioned Tracer as a potential digital twin type of solution as well. So positioning Power BI as a way to use building information modeling, three-dimensional information combined with the real-time data that might be coming out of a facility. So these three platforms are available for trial and download today. You can go to our PG Apps website and get access to them and kick the tires. But today's presentation is really about kind of a bigger story, a story about how you can take your platforms that you're likely using in practice, Rhino, Revit, and Power BI, and stitch them together in the context of a design scenario. And what you're seeing on screen here, not to kind of take thunder away from Nicole's demo, is kind of what the end product starts to look like, wherein you have geometry coming from Rhino, some information coming from Revit, and even an IFC file being presented and brought together in a report that tells the story about a design condition. And then we're able to use the data about that design and explore it within a report that you are able to design to satisfy your use case. So with that, I'm going to pass the mic over to Nicole, who will have some of the technologies available for demonstration. I think so you're going to be seeing a live version of everything that you saw, and along with that, I think some really exciting discussion. I will highlight that if you have questions, there is a Q&A a form in the Zoom, so please type your question there, and I'll be here in the background, hopefully providing good answers, and we might have some further Q&A at the end. You're also free to type in the chat, although the chat is not as conducive for Q&A, so if you just want to leave a helpful comment, please feel free to do so in the chat. But Nicole, the floor is yours.
Great, thank you. So you did steal my thunder a little bit because I really wanted to show these sliders in action, but that's all right. Let's take a second and just talk about what you're seeing here. Obviously, this is a dashboard. It's describing the conditions of these different panels on a facade. But what it's really doing is using the tracer visual and the Semantic and Tracer exporters to push together or overlay information from 3 different types of files. So we can use this slicer to toggle through these elements, and you can see these panel elements came from a Rhino model. This interior architectural core came from a Revit model, and this third structural framework model came from an IFC file. And we're using Tracer and Semantic, which has a very similar exporting condition to Tracer, to be able to structure these databases that are driving these visuals in a similar way, allowing these to be overlaid. The use case behind this dashboard is perhaps you're toward the beginning of a design and you are trying to develop a facade and overall building shape that meets various requirements. So the coloring that you're seeing on this image is being generated in Rhino to describe the degree of warp that are on these panels. So as the panels are becoming darker and darker in that orange color, they are having more warp. And then if we navigate to the second page, we've done a different type of analysis that might show which of these panels are similar. Similar type panels can probably have some advantages in construction and costing. So this could be another type of analysis that you could do with an overlay of tools like these. In order to be able to do the demo, we came up with something relatively specific like this. But as I go along, we'll try and make the conversation generic enough to see how you could apply this to a lot of different types of use cases. So with that, we will just jump right into Revit and start to show the process of how we're using these tools together to be able to create an overlaid dashboard like this. So I have a Revit model open. This is just the core of a building. You could imagine in a firm that this might be an off-the-shelf model that you have when you're getting ready to start a project of a certain size, or maybe a core designer has put this together to meet the needs of your program. And we're able to, if I open up Rhino inside Revit, and actually I'm going to show you how you could do that using our Conveyor UI. I already have it instantiated, but within this ribbon window, if you have Conveyor and Semantic and Tracer installed, there will be a Proving Ground tab, and we have a Start Rhino Inside button here. And then next to it is a button that can open the Rhino UI. So I've done that in preparation for the demo. We have here just a blank file, and you can see our Conveyor and Semantic UI are off to the side. And with this, we've created in Semantic a series of property groups. If I open the property group manager, you can see how we're starting to create these, but we've set up a way that we can control the overall shape of the tower with these various variables created in the property group editor. And if I open the Grasshopper model, you can see that we are reading in the properties from the Semantic UI using these semantic nodes that are available here in this Proving Ground tab. So we're reading in these semantic reports that are being generated from these controls. So when I toggle, I turn the preview on. Actually, I can take that off screen. When I change anything in this UI, it will start to change based on how that Grasshopper script is written, the shape of this tower. So you could imagine this being used to change really any type of variable that you're controlling in Grasshopper. I do want to mention we're showing some maybe slightly more advanced techniques today. To use Semantic and Conveyor, you don't need to know how to use Grasshopper at all. This is just utilizing those tools in Grasshopper to be able to do something a little extra special. So you can see that within this UI, we've created floors that are coming out at the end, and also these individual panels. We are going to send the floors directly to Revit using these conveyor nodes here. So you can see,
Nicole,
go ahead.
One thing to highlight, and I don't know if you're planning to do it after this step, but bringing the core into Rhino.
Oh yes, that is in my notes. Let's do that first so that we can, as we are changing the shape of the tower, we can see how that is affecting things. So in order to do that, because we're using Rhino inside, we'll select the geometry in Revit, go back into the Conveyor UI, drop down to Rhino and Revit Direct, and let me turn off the Grasshopper preview before we do that. And then we can select Get from Revit, and you can see that it will pull in directly those elements straight from the Revit file. Thanks for the reminder on that, Nate. I was getting ahead of myself. And this is a little unusual that it was saying not responding. Typically, we'd just be able to see it generating.
Yeah, there might be sometimes Zoom introduces a bit of latency into the processing, but I think one of the key takeaways here is that process of leveraging Conveyor with Rhino inside as a property is this ability to stream your geometry directly into the Rhino environment, and you're able to see the the resultant geometry is now Rhino based. And so one might use this as a way to provide some additional context to their project and coordinate some key design features across initially.
Okay. It looks like it's still thinking, but I'm able to control, so that's a good sign. If I turn this preview back on, now we can see both of these elements together, which is nice to be able to verify your design. Another thing that we can do is if I pull out the semantic window and move this out of the way, I can turn on within the Rhino inside ribbon the grasshopper geometry. So we can continue to refine this geometry from within Revit. This could be a use case where perhaps you have someone on your team who is able to develop these form finding scripts and other people on your team who are fine tuning a design. And maybe then they only need access to this remote control panel to be able to change their design directly from within Revit without really needing to learn any Grasshopper or Rhino. While I'm here, I'm going to adjust these settings to something that I know will work and display some variety in the shading. And finally, there we go. So it is a relatively quick process of the program reading these variables, and then it's a fairly lightweight script. Obviously, it depends on what you're doing with the variables, and that will affect how quickly it regenerates, but that reading process is fairly quick. So now that we have that form created, we're going to use a conveyor function in Grasshopper to start to send geometry directly from your Grasshopper script using Conveyor back into Revit. And if I turn off and take these things off the screen so that you can actually see this happening. Let me turn this off as well and toggle this to true. This will start to send that pathway. There's a progress bar off screen, but this will start to send the geometry that we created back into Revit. So now these are here. We can actually edit the shape of these. They're native elements in Revit. Don't attach. So these are all able to be edited within here, and they are created as this generic floor type, which we've set up using the script. So there's a lot of possibilities here to be able to add a material name that it will match up with in Revit and other properties and values, including their family and type. Cool. Okay, so we have the floors created now in Revit, and this will actually complete our Revit data set. So from here, we can export this data set as a database to be used in Power BI for our overlay. To do that, we'll navigate back to the Proving Ground screen and open our tracer exporter. So using Tracer for Revit, this UI will open as a plugin to Revit. I'll show you Tracer for IFC in a bit, which will open as an app on your desktop. And as you open it, you can adjust these 3D settings. You can export 2D and 3D geometry. Generally, smoothness when you open the app should be set to 0.1. This is optimized for speed and file size. Because I've changed it in the past, it usually opens up at 0.6. So that's something you'll want to be aware of if you are editing your settings. You can choose whether or not to filter the categories that you may select to those that are active in the view. It makes sense in our use case to do that. And then because railings are a little complex in terms of geometry and not really necessary for this type of report, I'll uncheck those. Everything else looks correct. And then we can select to export. We'll give this a file name. And it will save as a SQLite database. There is a progress bar off screen. Here we go. So it is taking all of the properties and mesh geometry of those elements and creating a SQLite database for those. We can go back into Rhino at this point and reopen Grasshopper. So we have generated these geometries, which are visible in the, sorry, I'm thinking a couple steps ahead. So we've generated these geometries and we're now able to bake these out with their properties. So I'll show you just really quickly how this function works. We are writing which properties we want each of these panels to be embedded with using the semantic functions, including things like their panel length, width, and warp. And we have written all of those to the objects, and now we're able to bake using this bake function, the objects that will already have those properties assigned to them. So rather than selecting objects and then assigning them in the property group manager, this allows us to just directly bake those. And let me make sure I send this back to false. But it allows us to bake those with the properties already embedded. So we'll toggle this on to true, and you can see if I turn off the preview, and I believe we're actually done with Grasshopper. All of these have been baked and they are on the layer which we've asked them to be on. So we can select them. And we can choose to export selected objects with the new version of Semantic, version 3. it comes with a database generator that is structured very similarly to the way that Tracer is structured. This allows us to overlay those types of information, as I mentioned before, because they're both similarly structured using SQLite. This will save out the Rhino model. And my computer has been having a little bit of glitchiness when it comes to exporting these out while using Rhino inside. So I do have a backup file ready if need be. But that seems to be a problem that's isolated to my machine. There it goes, as expected. So here is the backup. We will just do that step one more time, select these objects and export them. And you can see that it is indicating progress down here in the Semantic UI. Okay, so that's 2 out of the 3 data sets. The third is supposing we received a structural model in an IFC format, and we can use, this is the Tracer for IFC exporter that is opened as a desktop app. What it asks you to do is select one or more IFC files, so we'll do that here. All of these types of information are available, and you can select which ones you want. You can also adjust your mesh settings. And once again, you can hit export. All right, so all 3 of those are ready. We can go back into Power BI, and I will open a template that will allow us to import these easily. We do have templates available on our website for conditions like this, where we're combining more than one model type. And this is opening off screen. So I will need to reopen it once more so that I can show you this importing process. All right, so when you open a template, you'll see these fields where you can place data. Generally, they will ask you to paste a file path. We'll navigate in our browser to find these files. So the Rhino DB file path is here. We can right click, copy as path, and then paste. You'll notice that it comes in with these quotation marks, and that is okay. You don't need to remove them. Again, right click, copy as path, and paste. And then once again, as it's loading, it will ask me various times to authenticate each of these databases. I'm selecting default or custom. You can also select Windows and authenticate with Windows. This privacy levels message you'll get from some of your exported data sets, and you can just choose to ignore. And one more time. Okay, so now we can see that that was all brought together. We could use this to coordinate and study maybe areas for improvement in the design and to make informed design decisions overall. Another thing that we can do is come back into Rhino. I'll remove these objects. And we can actually make a change to this data set, re-export it, and reload it just to show how quickly that is able to happen. So I've changed the number of panel divisions, which will change the warp and the length, basically all of the properties of the panels, including its appearance. I will rebake. Actually, I did already rebake. I left that set to true. And we can select those objects, export them. We can save over the previous data set. Again, here's the progress indicated in the UI. And then back in our report, we can refresh the data. And this view is regenerating. So that just shows how it's relatively simple once you have those pathways established. If you do make a change, you can send that data back through and it will regenerate. So with that, I think I can pass it back to Nate.
Great. I was just in the midst of answering a few questions that came up. And maybe what I can do is answer this final one live, but I will review the other ones here just to bring everyone up to speed. So if you're interested in some of the Q&A that's been occurring, you're more than welcome to check it out under the Q&A interface. The first one was a helpful tip, at least on a potential issue with a recent version of Revit's service release and its effect on Rhino inside Revit. We will certainly be looking into this to see what impact this has on our tools and integrations that we're building that rely on Rhino inside Revit. Just seems that maybe a service release has introduced an issue with Rhino inside, which is of course authored by McNeil. We'll be checking that out. The second question is related to geometry generated as floors and some of the resultant outputs. So the question was like, does a floor, when it's pushed into Revit, assign to the appropriate level? And are there parameters and types? And the answer to that is yes, depending on what your input geometry is. So as Nicole was showing, she was passing in surfaces that have an assigned floor type to them. And so that produces a native Revit floor object that's editable. You'll see in the Q&A as well that I've provided a link to some of our documentation that includes information on how relative geometric inputs can convert to different Revit objects. So we've tried to do our best to expose how inputs and resultant outputs occur, and those are available in our documentation side. There is a question about the ability to have the workflow function with multiple Revit, Rhino, and IFC databases. And we do happen to have a few tutorials out there on using Power BI's ability to connect to multiple database sources. And Power BI's data transformation ability lets you really combine, say you have 5 Revit models, a couple of Rhino files, and some IFC databases. Power BI is built to connect to those sources and combine them together using its interface. And we do have a few tutorials, and I highlighted one in the Q&A that lets you, it exposes how that can happen. So a couple of other questions that have popped up, templates that we have are meant to do a couple of things. The one question here is related to the templates are available, and our example shows 3 connections being made, and you can download those from the site and see how they're put together. The nice thing about Power BI templates is that you can reverse engineer them pretty easily in our view, and can expand on them or build new templates based on the techniques that are there. Let's see here. Previous question about IFC integration. You must generate. Yeah. So everything that you're showing, that we're showing in this particular session, is occurring using the apps that are downloadable on the website. They don't require any additional server client infrastructure. They can be used locally on your desktop. That has advantages when it comes to your ability to quickly start making use of your data, but it may not scale as well to a kind of more kind of server-oriented centralized data solution, which requires more infrastructure and far more setup. So there are trade-offs here. There's clearly lots of ways that you can manually handle, as Nicole was showing, the exporting of data to keep things in sync. But there are automated solutions. I'm going to be talking a bit about what we're doing here in the future to kind of expand on this. Is it possible to import the parametric model from Grasshopper into Power BI? Importing the parametric model, no. Power BI is a read-only interface, so it's not going to allow you to generate more data within Power BI. However, if you generated, say, 50 options of a project in your Rhino model, and say you baked those out to various layers, or you assigned through Semantic a tag that indicated which option, which geometry belongs to which geometry, and then it is certainly possible to have those available in Power BI and have it be a searchable kind of interface. And why don't we use this as a departure point, maybe to share my screen here and kind of give you an overview of where you can start to learn more about this process. So these apps and the documentation for the apps are available at apps.provingground.io. And this question is related to Semantic. So I'm going to go to the Semantic documentation and find the an example that speaks to this. So we do have a number of 3D dashboard examples that have been published to the cloud from Power BI. And one of those examples is this design option comparison report. And this design option comparison report was kind of created with the idea that a user may want to put together a Power BI report that allows them within a client meeting, or maybe it's shared with a client for possible building design examples, and a report that also kind of expresses the trade-offs of those examples. So what you're seeing here is a single Rhino model that has several design options saved out to the Rhino model, and they're flagged as option 1, option 2, option 3, option 4. And data about each of these design options by way of area, revenue, calculations that are kind of baked into Semantic are also being presented here. So this becomes a way for you to use the Power BI interface to kind of analyze these design options and drill down into maybe comparing one option over another, and looking at the trade-offs that might be in play there. So one could I could speculate that if you have a model in Grasshopper that's producing design options and you're baking them into a Rhino model context, or exporting them through some of the methods that Nicole was showing, that you could have a searchable essentially database that can be presented in this manner in 3D. But to kind of round things out here, I'm going to share just a couple of thoughts about what's next and some of the things that we're working on that might be of interest in terms of how these products might scale in the future and can scale to kind of more enterprise context. The first thing I'm going to talk a little bit about is Tracer Server. So the version of Tracer that is on the website is kind of, again, a standalone product that exists on your computer's desktop. Tracer Server is a data harvesting framework that allows you to take multiple Revit models that exist across your business portfolio and push them to a single centralized database server. So what this allows you to do then is have all of your models existing in a common data environment. You can search that data environment, you can find information about the models and the content within the models, and then you can start to produce reports that suggest different use cases. So what you kind of saw there was this ability to go through different models, compare areas, and perhaps even integrate that data that is on the server with other data sources that might be in your business's data warehouse. So maybe you're collecting other information about the built environment. Maybe you're collecting post-occupancy data. Maybe you're a building facility owner and you have maintenance requests. Tracer Server and this kind of centralized BIM data resource can become an asset for really leveraging the data that's in these models. As a component to this is something that I previewed on Twitter in the last week. We know that platforms like BIM 360 are being used to house your Revit files and collaborate on those Revit files. And our Tracer Server framework now allows you to have integrations with BIM 360 wherein you can access the cloud model and start the harvesting process and do some data collection of data that might be currently on BIM 360 and in Revit. Tracer Server can be used to essentially harvest data out of that environment into a database that you own and you maintain. So you have access to your data outside of the BIM 360 cloud, for example, and you can start to data mine out of that cloud. A kind of a pitch in some ways to our AU presentation next week. We are going to be at Autodesk University in New Orleans, and we will be presenting a project that we were a part of with Harley Ellis Devereaux, wherein we implemented a framework for automating Revit model creation from the cloud. And so what we've done here is using similar sets of technology that you saw with harvesting of data from BIM 360 models. This is about the opportunity to create new models based on project standards and other criteria in your business. And the use case here is to say, hey, we have a new project that's starting. We want it to comply with certain standards in our practice. This runs Revit as a background task worker, develops the standardized model for a project discipline, the project criteria, creates it in the cloud, and then project teams are getting a starting point with a standardized model that can be used for further development. So we're really excited about this process and how Revit can be used as an automation framework to get teams started on common standards in your practice at a pace that is consistent with the needs of increasing speed that teams are expecting to have going with their projects. And then finally, I wanted to highlight the kind of data centralization opportunity again, this idea that with these frameworks for centralizing model data, harvesting and collecting data, and presenting it, we are ideally enabling a collaborative opportunity wherein we can access this data in a manner that is using existing tools. So here you have we did a lecture last year, almost exactly a year ago, about digital twins and business intelligence. And this is an example of how Tracer's ability to export building information model data into a database environment can be combined with other data that might exist about the facility regarding maintenance, post-occupancy, environmental quality, and performance, and combine it together in a report that tells the story that a business might need to make decisions about their built environment. So this idea of connecting data together, giving stakeholders ownership and the ability to leverage this data, we see as imperative for the continuous improvement of the built environment, and the ability to make decisions, important decisions about a project as it's being designed, and also operated. So with that, I will, we can kind of conclude, and let me just check to see if there are any lingering questions here. It looks like, so there's a few, let's see, we need to generate this data in specific setup or configuration. Are all content categories and subcategories? So the exporting process, I believe this is related to the exporting process of Tracer, and potentially Semantic. The harvesting process uses the underlying data that's available in the model. So if you have objects on categories, and those objects have different properties assigned to them, those are being pulled out in a kind of common data structure. So there's not much configuration that you do. I think the one point that I will make is that your models, the process of leveraging data and making good decisions about the data in your models is really contingent on your models having good data. And some of the things that we often see firms struggle with is how they can create models where there are consistently applied identifiers and properties across multiple models. And so we're big advocates for data standards. We're big advocates for firms enabling a level of consistency and quality in their project. The one question is there are models that might be on BIM 360 that have 100+ links in the model, as I understand it. Is the Proving Ground able to automate that process of automating, opening up each link and harvesting it? And the answer to that is, I think, found in our Tracer server implementation. So what we're able to do with Tracer server and what's happening there is that Revit is operating as a background task worker. And so if you have a project that has many links, you are able to send those models to the task worker, and Tracer server takes on the process of harvesting them so the user doesn't have to open up each one, essentially. So that's kind of where we go from standalone, desktop-based application to something that is more of a cloud-based automation process that we're really excited by, with how these concepts that were shown in this workshop can scale to larger use cases with the tools that we've been designing and developing. So with that, I think we can conclude this discussion. We were excited to show some of the latest updates on the toolkits that we're defining, but I think moreover, we wanted to do this demonstration that shows that not only are these apps useful on their own for particular use cases, but then they can be linked together and used to tell an overall story for how data and workflow and interoperability can be leveraged across a project context. So thank you very much for your time. I hope I was able to get to everyone's question. This session has been recorded, so you can expect a publishing of this session on YouTube in the coming day or so you can refer back to it. Or if you missed it, you can rewatch later. Thank you very much. And thank you, Nicole, for the demo.
Oh, thank you. Thanks, everybody.
We'll talk soon.